Hey Python bros, let's talk about A/B testing and what statistical tests you use to prove whether your A/B test had a significant improvement. I'm going to be using discrete KPIs and we're going to focus on a very popular gaming metric called retention. What we'll cover today will be applicable for any discrete metric that you have, so stay tuned. Let's eliminate bias and make sure that our data insights are relevant, significant, and are really gonna improve our product or game. Hell yeah! Retention is a discrete KPI. It's measured as a percentage. It can go from 0 to 1. The first step we need to take is figure out if our A/B test had enough sample sizes to reach power, and based on that, we either use Pearson's chi-square test or Fisher's exact test. In most cases, the results of both would be the same. We're going to be importing a bunch of statistical tests, NumPy, Pandas, and math. Nothing overly complicated. Ideally, you should be familiar with those, but even if you're not, don't be afraid. I'm going to make it very easy and digestible for you. In the GitHub below, you're gonna find all of the code from today's video. I've also attached a day 7 retention data CSV that we're gonna use as a case study. In the dataset, I have user IDs, the test group of the A/B test they were in, 0 is our base or control group, whereas 1 is our variant where we changed something in the game and we're trying to see if it had a positive effect. Retention day 7 is basically the ratio of players that came back on their 7th day after installing the app. If they came back to the game, the value is 1. If they didn't, the value is 0. That's gonna be our raw data. Okay. Enough prep work. We know our metric is discrete. Now we have to answer the question, is our sample size large? Let's go ahead and aggregate our data by test group. We're calculating our day 7 retention rate, and we see our control group has close to 4.5% retention, whereas our variant has close to 5. Now we have to answer, is this uplift significant? Or is it due to random noise? To do that, we're gonna conduct a power test. Don't be afraid, I know it's a lot of code, but it does some very simple and easy to understand steps. Forget about alpha and power, feel free to fix them at 5% and 80%. Those are commonly used and they're pretty much accepted as the industry standard. The only thing we have to input is our retention rates. We have our base group and our variant. It's pretty easy. It's plug and play. We arrive at a result of almost 32,000 samples. In order to be confident that we can eliminate noise, we need to have 32,000 samples per variant. In our test, we have a little bit over 28,000. This is within margin of acceptability and is one of those gray areas that you can use both tests. Let's create our contingency table. It's going to be the base that we feed into our statistical tests. Since we already have our retained users, the only thing that's left is to have our non-retained users. A quick pivot. And this is what our contingency table looks like. We have both variants, we have retained users and non-retained users. We're ready to go. We're gonna start with the example where we don't have enough sample sizes. Since we have 28,000 and we need 32, let's do Fisher's exact test. A lot is happening under the hood, but all you really need to know is it uses a hypergeometric distribution to arrive at the conclusion whether the difference between the two variants is significant enough. The output is a p-value, and we're looking for that p-value to be under 5% or 0.05. Our function takes the contingency table as input, and bam, we're a long way from 5%. We can confidently state that our variant significantly overperformed our control group. The change we introduced has a statistically significant impact on our game. And in this case, it's positive. Before we go ahead opening champagne bottles, let's also see what happens when we use Pearson's chi-square test. In a real situation, I wouldn't really care about the 4,000 missing samples, and I'd go ahead and use this test. The major difference between the two, here we use a chi-square distribution, and we don't really compute the actual p-value, we approximate it. You don't really need to fully grasp the 200 years of statistics that go into a few lines of code. If you ever have some time, read up a bit on statistical tests. Once you use them a bit, it's super interesting to understand the underlying math. For now, let's just do the test. Our function takes the contingency table as input again. Bam! Our p-value is quite far away from 0.05. Both tests independently prove that our feature works. Since our retention increased, we can happily implement it and roll out to all users within our game. Awesome! Our game or product is now better. And now we can test discrete metrics in both large and smaller A/B tests. To give you a real example, I'd use chi-square tests on the overall test results, but when I break them down into countries or platform or user segments, generally the sample sizes get smaller. One such example is to stratify by payers. If we exclude all players that haven't purchased anything within the game and just look at those that monetize, we're gonna get a much smaller sample, so it's a good idea to change our statistical test. And that's all for this video. I hope you managed to learn something new, and hopefully now you're more confident in your A/B tests. Let me know if you managed to reproduce it with the data I've given you, or if you try it with your own data. I'm excited to hear the results, or take a look if you have problems. I thank you for taking the time to watch this video. Feel free to subscribe to the channel. I'll be following up with a video on continuous statistical tests, again for A/B testing, and we get to wrap the whole topic. As always, stay awesome, stay Gucci, and until next time. Hell yeah!